Hi there, this is Magnetism Lesson 8. It's alternating current, RMS, which is root mean square, and peak values with efficiency style exam questions. So a pure A-level lesson compared to the previous GCSE recap stuff. So first of all, alternating current, RMS and peak values. So you should have done this before in electricity. But the alternating current, so that would be the RMS, the root mean square value. So current RMS, average current, is equal to the peak value of the current, which can be I0 or IP, call it IP for peak, divided by root 2. That's it. And then the next one you might need, VRMS, so the average voltage, is the peak voltage divided by root 2. So you want to make sure you've got these down. These are on most data sheets. And then we'll move on. Right then, so I want to pause and have a go at this one, and then I'll take you through the answer. So a main transformer has a primary coil of 2,500 turns and a secondary coil of 130 turns. The primary coil is connected to the main supply, where the VRMS is 230 volts. The secondary coil is connected to a lamp of resistance 6 ohms. The transformer is 100% efficient in this case. What is the peak power dissipated in the lamp? So quite a convoluted question, there's a lot in it. So let's have a go at solving it. So we've got resistance and we need the peak power. So with resistance, if we have voltage, then we can just use power is V squared over R. So I guess the thing that we need to do is find the secondary voltage, which we can do using the transformer equation. So the voltage primary divided by the voltage secondary is equal to the number of turns on the primary divided by the number of turns on the secondary. So we've got 230 on the primary coil divided by voltage secondary equals number of turns on primary divided by number of turns on secondary. So it's 2,500 divided by 130. And if we rearrange to get VS, so the voltage secondary is equal to, so it's 230 times 130 divided by 2,500. That gives a voltage secondary of 11.96 volts. So I'm going to clear this. So the voltage secondary is 11.96 volts. Now that's the RMS voltage, because we were given the average voltage for the primary coil. So we need to find the peak voltage because the question wants the peak power. So we've got VRMS is equal to voltage peak divided by root 2, which we wrote down a minute ago. So VP over root 2. So if we do the average voltage times root 2, that'll give us the peak. So we've got 11.96 times root 2. That gives the peak voltage of, and it'll be 16.914 volts. Then we can do, quite a long one, power is V squared over R. So just square that value and then divide it by 6 for the resistance. So if you do that, you get a power that is approximately equal to, well, it rounds to 48 watts. So like I said, much more difficult than what we've done in previous lessons. Hopefully it went okay though. Let's move on. So efficiency of a transformer. So the efficiency, well, any efficiency is the useful divided by the total. So the useful in this instance will be the power of the power output of the secondary coil. Power output of the secondary coil divided by the power input on the primary coil. And what we can do is obviously use an equation for power, which is IV. So efficiency could be IV, so current on the secondary, times voltage on the secondary, divided by current on the primary coil, multiplied by voltage on the primary coil. Obviously current's measured in amps and voltage is in volts. Efficiency is just a decimal or a percentage. So that's the equation. Let's write it out. Efficiency is equal to ISVS divided by IP VP. Sometimes it's not necessary to do current times voltage, you can just use power. But it'll depend on the question. So let's move on, let's do a practice question. So let's pause and have a go. A transformer has 1150 turns on the primary coil and 500 turns on the secondary coil. The primary coil draws a current of 0.26 amps from a 230 volt AC supply. The current in the secondary coil is 0.5 amps. What is the efficiency of the transformer? So in this instance, we've got the primary voltage, we've got the primary current, and we've got the secondary current. So the efficiency is the secondary power divided by the primary power, but we're missing the secondary voltage. So we've got to find that first. So voltage primary divided by voltage secondary equals number of turns on the primary divided by number of turns on the secondary. So let's put our numbers in. So it's 230 divided by VS equals, and it's 1150 divided by 500. So voltage secondary is 500 times 230 divided by 1150, and that gives a secondary voltage of 100 volts. Now I'm going to clear that. Then we can do efficiency. Is the secondary power output divided by the primary power input. So IS VS divided by IP VP. Then it's just a matter of putting the numbers in. So the current on the secondary, 0.5 times 100 volts for the secondary, divided by 0.26 on the primary, and then 230 volts on the primary. So that gives 0.84 or thereabouts, and it rounds to 84% for the efficiency. Hopefully that one went okay. Let's move on. So we've got another question. If you want to pause and have a go. A lamp rated at 12 volts, 60 watts is connected to the secondary coil of a step-down transformer and is at full brightness. The primary coil is connected to a supply of 230 volts. The transformer is 75% efficient. What is the current in the primary coil? So we can simply use the efficiency equation. So efficiency is the secondary power divided by the input power. Secondary power divided by the input power, power in the primary coil. So the power in the secondary we already know is 60 watts. So efficiency is equal to, so we've got 60 watts divided by power in the primary, which is current on the primary, times the voltage, which we already know, is 230. We know the efficiency is 75%. So I'm just going to clear this actually, tidy it up. So we're going to get, I could have done that a little bit better, but it'll be okay. So 0.75 equals, we've got the 60 watts divided by, and then it's the current on the primary coil times 230. So we've got current primary times 230 equals 60 divided by 0.75, and 60 divided by 0.75 is 80. So current on the primary is equal to 80 divided by 230, which gives us a current of 0.35 amps. Hopefully that one went okay. So we've got one more. Bit of a convoluted one, but if you want to pause and have a go. So a 230 volt, 60 watt lamp is connected to the output, so that's the secondary, terminals of a transformer, which has a 200 turn primary coil and a 2000 turn secondary coil. The primary coil is connected to an AC source with a variable output PD. The lamp lights at its normal brightness when the primary coil is supplied with an alternating current of 2.7 amps. what is the percentage efficiency of the transformer? So if we start with that, the efficiency that we're looking for is the output power, or the power on the secondary, divided by the power on the primary coil. The power on the secondary we already know, which is 60 watts, divided by, and power on the primary is current on the primary multiplied by voltage on the primary. And we know the primary current is 2.7 amps, so we need the primary voltage. So as soon as we get the primary voltage, we can finish this question. So let's do that. So voltage primary divided by voltage secondary equals number of turns on the primary divided by number of turns on the secondary. So I want primary voltage, so Vp divided by voltage secondary is 230. Number of turns on primary is 200 over 2000 for the secondary. So that's 1 over 10. So the voltage primary is simply, if we rearrange, 230 divided by 10. So voltage primary is 23 volts. Then we can sub that into the efficiency equation. So you want to make sure that's written down. So efficiency, once again, is power on the secondary divided by power on the primary. Now we know everything. So power on the secondary is 60 divided by power on the primary. So it's the current times the voltage. So it's 2.7 amps times the voltage, which we just calculated, 23 volts. And if you put that in your calculator, that will give you an efficiency of 97%. So that lesson was a bit trickier than the previous ones on transformers, but that's the A-level standard for the calculations. Remember to make sure that you know how to improve the efficiency of a transformer, and then you should be set for your exam. So I hope you enjoyed that one. Thanks for watching. I'll speak to you soon.